So in this video, we're going to look at solving absolute value inequalities. In particular, when we have the absolute value of an algebraic expression being less than a real number. So to kind of summarize, absolute value equations and inequalities can be broken into 5 cases, right? We have 5 symbols we're working with: equals, less than or equals, greater than or equals. So these 5 symbols correspond to 5 cases that need to be talked about, because those are the cases we might have to solve. Case 1 we've already done in a previous video. What we want to recognize is that case 2 and case 3, where we have either a less than or equal, they're related cases, and the solution process is the same for both of those 2 cases. Case 4 and case 5, where we have either a greater than or equal to symbol, those are also related cases and have the same solution process. So in this video, we're going to be talking about case 2 and case 3, which is an and style inequality. So these inequalities can always be rewritten as a single statement where the variable lives between the bounding numbers, or on a number line where we have a line interval between 2 bounding numbers, or an interval notation where we have just a single interval needed to express the solution. This is going to be the common way of expressing solutions to these types of absolute value problems. So we're talking about the less than case, or the less than or equal to case. They're essentially the same case with a subtle difference in terms of how you describe the final solution. But if we look at just a concrete example for a minute, let's say we have the absolute value of x being less than 5. What does that mean? Well, remember, the absolute value symbol describes a distance, right? The absolute value of something is the distance it is from 0. And here we're saying we want the distance that x is from 0 to be smaller than 5 units. So if I think about 0 on a real number line and a bounding number of 5, to be less than 5 units away from 0, I'm going to need to live somewhere in here. But if I go over to -5, I also know that anything between -5 and 0 is going to be less than 5 units from 0 as well. So it turns out that because we don't have the equality symbol on the 5, we put 2 open circles on the 5s because those are our bounding numbers. And when we're working through these types of problems, it's always a question: do the solutions live to the right and the left of the bounding numbers, or do they live between the bounding numbers? And in this case, to be less than 5 units away from the number 5, I have to live between the bounding numbers -5 and 5. So there's where I would have to live on the real number line. And if x has to live between these 2 numbers, I can just say that. I can take this statement and write it in an equivalent form, saying that I have 2 bounding numbers and x needs to be between them. X needs to be greater than -5 and at the same time less than 5. I have to meet both criteria, which is why it's an and style of a statement. So if I make this more generic, and I go up here and I say an algebraic expression has to be less than or equal to some bounding number k, where k is a positive real number, that tells me if I have my 0 and I have some number k and I have the opposite of k, that to be less than or equal to k units away, because of the equal to, I would put solid dots. And to be less than or fewer than k units from 0, I would need to live between k and -k to be less than k units from 0. So let's look at solving a problem. So we're going to solve a problem that is basically a less than or equal to style problem, which means we're going to be able to break it into a single expression or statement. So rewrite the problem. How exciting is this? And the goal is the same as it was for an absolute value equality. It's isolate completely the absolute value symbol before you do anything. So here, to isolate this absolute value symbol, my first move would be subtract that 6 from both sides, and I'd get 8 minus 6 is 2. 6 minus 6 is 0, which would leave me with absolute value of 3w minus 2 over 2. And then I'd want to dig that 2 out of the denominator, so I would multiply both sides by 2. So I'd get less than or equal to 4. 2 divided by 2 is 1. 1 times the absolute value symbol is just the absolute value of 3w minus 2. And now I've completely isolated my absolute value symbol. And before I continue in the solution process, let's just talk about what this means. This means that if I'm on a real number line, the algebraic expression 3w minus 2 has to be less than or equal to 4 units away from 0. So if here's 4 and negative 4 and I have an equal to, I'm going to put a solid dot and a solid dot. And to be fewer than 4 units away from this number, I'm going to have to be between negative 4 and 4. If I'm over here, I'm more than 4 units away from 0. If I'm over here, I would be more than 4 units away from 0. So 3w minus 2 has to live between negative 4 and 4 to be fewer than to be a distance less than 4 from 0. So that tells me that I can break this now out into a 3-part inequality. I have 2 bounding numbers, negative 4 and 4, and 3w minus 2 has to live between them. So now I have a 3-part inequality. So I'm going to solve this the same way that I would a 3-part equality. I'm going to work at isolating the w on the interior. So I'm going to add 2 to all 3 sections, which is going to leave me less than or equal to negative 4 plus 2 is negative 2. I get a 3w in here because minus 2 plus 2 is 0. I get 4 plus 2 is 6, and then I would step over here. And we would divide by 3. Make sure I wrote everything right. Divide by 3, divide by 3. And this gives me a negative 2/3 less than or equal to a w, because 3 divided by 3 is 1. I get 1w is less than or equal to 2. 6 divided by 3 is 2. Just double check my work real quick. I did the 8 divided, that was 8 minus 6 to give 2, multiply by 2 got 4, add 2. I think it looks good. So if I'm thinking about a number line, what this is saying is that for 3w minus 2 to live between negative 4 and 4, we're going to need w to live between negative 2/3 and positive 2. So on the number line, the final answer, because of the equal to symbol, I'd have solid dots. And I would just draw the line segment connecting those 2 points. And w would need to live somewhere inside of here. I'm asked to express my answer in interval notation. So in interval notation, I would say w must be an element of the interval. It's a line interval that includes negative 2/3 and runs all the way up to 2 and includes the 2, so I use the square bracket.